This is chapter 1, homework number 1. Let's start with 1-6. Angela is working with function machines. She has the two machines shown at the right. She wants to put them in order so that the output of the first machine becomes the input of the second. Her initial input is 6. In what order must she put the machines to get a final output of 5? This is like we did in class. So we're going to have initial input of 6, and we're going to send it into the first function machine, and that's going to give us some mystery number, the output, and then we're going to send that right into the second function machine. Alright, and then that'll give us another output, and it says the final output should be 5. So now the question is, which order? Should this one come first, or should this one come first? And there's really no good way to figure it out other than guess and check. Let's try this one first, and then this one second. And that's y equals, sorry. Alright, so if we input 6 into this function machine, you evaluate this expression at 6. So that's just the square root of 6 minus 1. Alright. And the square root of 6 minus 1 equals the square root of 5. Alright, so this mystery number, the output is 5, and then we send that right into the second function machine. Okay, so then we replace x with our root 5, x squared minus 6. Okay. And this is kind of strange. It doesn't seem like it's going to give me 5. So I think I'll stop there. And if you're curious, the square root of 5, square and square root are opposites of each other. So they cancel each other out, leaving us with 5 minus 6, negative 1. That didn't actually work. So we're going to have to go back to the drawing board. Alright, and let's try reversing the order. So let's try x squared minus 6 first. And then we'll put the second function machine square root of x minus 5. Okay, so now that we've switched the function machines, substitute 6 into the first one. That's going to be 6 squared minus 6. When you square a number, it multiplies by itself 2 times. 6 times 6 is 36, and 36 minus 6 is 30. So 30 is the output of that first machine. Alright, and let me erase this so we don't think it's part B. So we get a 30, and the 30 goes straight into the second machine. And let's evaluate this. 30 minus 5, and then we take the square root of that. So 30 minus 5 is 25, and then the square root of 25 is 5. So that works. Alright, so the order is, in what order? That's the question. X squared minus 6 first, then root x minus 5. Alright, I'll let you do B. 1-7. Evaluate each absolute value expression. Okay, let's look at B. You can look at the math notes box if you need some hints. So this is going to be negative absolute value of negative 7 3/5. So the absolute value of negative 7 3/5 is just 7 3/5, right? Any number you put into the absolute value comes out positive. However, we still have the negative sign hanging out in the front, floating out front. So this negative sign kicks in, and the answer is negative. All right, let's look at C. C, we have the absolute value of 3 subtract the absolute value of negative 1. So what is the absolute value of 3? That's just 3. And then we're going to subtract, what's the absolute value of negative 1? Comes out positive, right? So it's going to be 3 subtract 1. That subtraction sign in the middle stays the same because it's not inside the absolute value. It's outside the absolute value. I'll let you do A and D. 1-8. Sketch figures 4 and 5 below for this tile pattern. Alright, so let's analyze this. Figure 1 has 3 tiles. Figure 2 has 5 tiles. In fact, these are the new ones that get added, so I'll shade them in. Figure 3 has 7 tiles. So you can see that the pattern is actually adding 2 tiles every time. Right? These are the 2 new ones in figure 3. So the pattern grows by adding 2 tiles. For each new figure. And it says to explain how you know. How did we know? Well, I looked at the diagram. Or let me call it the picture. I looked at the picture and counted. That's how we figured this out. And once we looked at the picture and counted, we figured out that it's adding 2 tiles each time. So if we go on to figure 4, it should have 9 tiles, right? So I'll draw figure 4. We'll also need figure 5. Figure 4 should have 9 tiles. Now if you notice, there's 1 in the corner. In figure 1, there's 1 on top of that block. In figure 2, these 2 tiles are on top of the block. Figure 3, 3 tiles on top of the block. So figure 4, we're going to have 4 tiles coming off of that initial block. 1, 2, 3, 4. And the same extends out to the right. 1, 2, 3, 4. So we should have 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. All right. I'll let you do figure 5, and I'll let you figure out how many tiles in figure 0. Explain how you know. 1-9. Simplify each expression. When you add 2 negative numbers together, negative 42 plus a negative 17, it's kind of like adding together the numbers, right? It's going to become more negative. So if we added them together without the negative signs, we get 59. All right, so if we take a negative number and we make it more negative, it's going to go further away from 0 on the number line and leave us with negative 59. They say if 2 numbers have the same sign, you add the numbers together and then keep the negative sign. So we added these 2 together and we kept the negative sign since they have the same sign. All right, part B. 8 subtract negative 9. When you subtract a negative number, those 2 negatives become a giant plus. This is just 8 plus 9, and that's 17. All right, when you have a number next to another number, we have a positive number next to a negative number, so we multiply them. And don't forget about this thing, right? We have a positive and a negative, so what's left? Negative. So our answer is going to be negative, and 9 times 8, best know those times tables, is 72. All right, I'm not going to do all of these. I'll just do G and H and let you do the rest. So G, we have negative 5 squared. Now be careful here. The negative sign is in the parentheses. So a square makes a number multiply by itself twice. Raised to the power 2, multiply the number by itself twice. All right, and since the negative sign is in the parentheses, that gets repeated. Now, remember this thing here. So if we have 2 negatives, it turns out to be a positive, and it's a positive 5 times 5, which is 25. Compare that to H. H is negative 5 squared. That means 5 gets repeated twice, right? But the negative sign is not in the parentheses. So the negative sign just hangs out in the front. All right, so we have negative, and 5 times 5 is 25. So these are different. You got to know that one. 1-10. For each equation below, determine the value of y if x equals 2. Okay, so we're going to substitute x equals 2. Let's try this one. Y equals 7 minus 3 times x. So that's just going to be 3 times 2. Y equals 7 minus 6. Don't forget to multiply first. PEMDAS. And PEMDAS has multiplication at a higher level than subtraction. So y equals 1. All right, now I'll let you do B and C. Same idea, plug in x equals 2 and simplify. 1-15. Draw figure 4 below. Let's count the tiles in figure 1. 1, 2, 3, 4, 5, 6. Let's count the tiles in figure 2. Well, figure 2 is just figure 1 with these 2 tiles and those 2 tiles added onto it, right? So figure 2 has 4 new tiles. And if we add 4 tiles, we get 10. And let's check that that pattern holds. Yep, figure 3 is just figure 2 with 2 new tiles on top and 2 new tiles on the bottom. So we add 4 to each figure. And let's see, that's going to be 14. So we can count them out individually if we want. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Correct. So figure 4, if the trend continues, should have 18 tiles. So let's draw figure 4. Now if we notice, there's 2 tiles in the middle, always. And if this thing has 18 tiles, that means there's got to be 8 on the top, right? 2 on the top, 4 on the top, 6 on the top. Now we're going to have 8 on the top. How many is that? 1, 2, 3, 4, 5, 6, 7, 8. And that means we also need the same amount on the bottom. So there's figure 4. Now, I suggest what you do here is just keep counting. Keep adding 4 plus 4 plus 4 to figure out how many tiles in figure 10. So if that trend continues where we add 4 each time, how many tiles once we're at figure 10? 1-16. Let's look at part A. We have x plus 5 equals 5. So x we need to make alone. There's no like terms to combine. X is on just one side of this equation. So what we need to do is take away 5. If we take away 5 from each side, 5 minus 5 cancels, leaving x equal sign 5 minus 5 is 0. That makes sense because 0 plus 5 equals 5. So x has to be 0. Part B. Combine like terms. On the left-hand side, we cannot combine like terms, but on the right-hand side, we have 3x minus x. And I'm sorry, let me write the left-hand side first. 2x minus 6 equals. So we have 3x minus x. That's 2x. But we also have a plus 1 and a negative 7. And a plus 1 and a negative 7 make, remember this guy? Oops, that doesn't apply to this. I'm sorry, ignore that. Plus 1 and a negative 7 make negative 6. Right, we have negative 7. If you add 1 to it, it goes closer to 0 on the number line. Now, we have the same thing on each side of the equation. So, because we have x on each side, let's take away 2x. And 2x minus 2x cancels, leaving just a negative 6. We have an equal sign, and 2x minus 2x also cancels, leaving negative 6. Alright, so x disappears. And we have negative 6 equals negative 6, which is actually true. Negative 6 is equal to negative 6. So what we write here is infinitely many solutions. And infinitely is sometimes written, sometimes it's not written. You can write many solutions if you want, or you can write infinitely many solutions. It means the same thing, so. Alright, you can do the other two. 1-19. Evaluate the expressions for the given values. Part A. Negative 2x squared plus 1 for x equals negative 3. So let's plug in, and we get negative 2. When you substitute a number, put it in parentheses. So it's going to be negative 2 times negative 3 squared. And we add 1. Now, when you square negative 3, it repeats, it multiplies by itself twice. So it's negative 2 times negative 3 times negative 3, because you know, you square it, it multiplies by itself twice. So that's just negative 2 times what? Negative 2 times 9, right? Negative 2 times 9. Negative times a negative, positive 9. Okay, so we have negative 2 times 9, and then we add 1. Do we multiply or do we add first? And we multiply, right? So we have 2 times 9, and that's 18. But don't forget the sign, because a negative times a positive stays negative. Remember this guy. A negative times a positive stays negative. So negative 18 plus 1 is negative 17. We're adding 1, so it's getting closer to 0. It's becoming less negative on that number line. So the answer, negative 17. Alright, and let's do D. D has an exponent, so it's kind of tricky here. 2 times 3 raised to the power x. So that's going to be 2 times 3 raised to the power 5. So that's 2 times. Now, when you have a number raised to the power 5, okay, we can just rewrite it like this. It gets repeated 5 times, right? When you have a number raised to the power 5, it multiplies by itself 5 times. So 2 times. Now this is a good one for your calculator, so I'll pause and get that out. You could do this by hand, but it'd just be a little bit of extra work. Okay, and here it is. Your calculator will have an exponent button. Mine is right here, x, y, so I do 3 raised to the power 5. And your exponent button might look like this little up arrow. 243. So it's 2 times 243. And again, you could do this one in your head, on paper or on a calculator, your choice. I'm going to do it on paper. 2 times 3 is 6, 2 times 4 is 8, and 2 times 2 is 4. So the answer is 486. 1-20. Create a tile pattern that matches the table below. Alright, so I'll do 2 just so you get the idea, but this one's actually should be pretty easy. Alright, so figure number, these are the figure numbers, figure 0, figure 1, figure 2, figure 3, figure 4. Alright, so we're going to need to draw all these figures. Figure 0, and then if you look in the number of tiles column, figure 0 should have 2 tiles. Alright, so there's my figure 0. Doesn't have to look like that, but that's what it is. Alright, and then figure 1 should have 5 tiles. So you get to decide how this thing grows. I'm going to put 1 up there. Actually, I'll put 2 up there, and then 1 hanging off the bottom. Figure 2. Figure 2 should have figure 1 in it, right? Should have figure 1 in it, but this one had 8 tiles. So 1, 2, 3, 4, 5. We need to add 3 more. So let's keep the pattern consistent. Let me put 2 hanging off the top, and then 1 on the bottom. 8 tiles. I'll let you do 3 and 4. That one's pretty easy though. Just draw figures with that amount of tiles. 1-21. Calculate the value of each of the following expressions. I'll do A and C. So for A, when you have a fraction, what you do is simplify the top, then simplify the bottom, and then at the end you divide the two numbers, because a fraction means divide. So looking at the top, we have 3 squared plus 2 times 8. So 3 squared is 9, right? 3 squared is just 3 times 3. Alright, so it's 9 plus 2 times 8 is 16. On the bottom, we have 16 subtract 11, and that's not too bad, right? 16 minus 11, that's going to be 5, and 0, so that's just 5. So what do we have? We have 9 plus 16 divided by 5. Now we still need to simplify the top. 9 plus 16 is 25. And 25 divided by 5, you got to know those times table, people. That's going to be 5. All right. Part C. Part C, same deal. Calculate the value. Simplify. Follow PEMDAS. So if we go inside the parentheses, there's another set of parentheses that we need to simplify first. So we're going to do that. Then we're going to add 2 to the power 3. Then we're going to subtract 5. Then we're going to multiply by 4 at the end. All right, so in the inner set of parentheses, 8 minus 10 times 3. Careful. PEMDAS. Multiply first. We do 10 times 3 first. So that's going to be 8 minus 30. Right? Multiply first. The subtraction comes second. All right, so then we have 4 times. Now 8 minus 30. You might want to use a calculator for that if you're not comfortable with negatives. Negative 22. And then we're going to add 2 cubed minus 5. Okay, so 4 times negative 22 plus 2 to the power 3. 2 to the power 3 is 2 multiplied by itself 3 times. 2 times 2 times 2. 2 times 2 is 4. Times 2 again, that's 8. So 2 to the power 3 is 8. So it's 4 times. Now if we get all these 3 numbers together, we have negative 22 plus 8 minus 5, and that's negative 19. And lastly, 4 times 19. 4 times 19, 76. Don't forget about this thing. If you have a positive number times a negative 19, answer will be negative. Solve each linear equations, check your solutions. I'm going to do just C, and you can do the other two. Alright, so C, 6x minus 10 equals negative 8 plus 3x. Combine like terms. Looks like all the like terms are already combined, so now, since there is an x on each side, we subtract or cancel the smaller x. In this case, we'll subtract 3x from each side. That's the smaller x. 3x minus 3x cancels. 6x minus 3x is just 3x minus 10, equal sign. What's left over here? Just negative 8 plus 0, or negative 8. Now we need to isolate x. Make x alone. We start by adding 10 on each side. So all that's left is 3x. Negative 10 plus 10 cancels. 3x equals negative 8 plus 10. Negative 8 plus 10. That's the same thing as 10 minus 8. That's just 2. And last step, divide both sides by 3. X equals 2/3. Now it says to check your solution. So let's do that. So we have our original equations, 6x minus 10. So that's going to be 6 times 2/3. Subtract 10. That should be equal to negative 8 plus 3 times x. So that's 3 times 2/3. We take our answer and we put it back in the original expression. Alright, 6 times 2/3. That's the same as 6 over 1 times 2/3. Alright, so let's multiply straight across. We got 6 times 2, which is 12, divided by 1 times 3, which is just 3. And over here on the right, we're going to multiply these together. And to multiply a number in a fraction, you put the number over 1, the whole number, and then you multiply straight across. We've got 3 times 2, which is 6, and on the bottom, 1 times 3, which is 3. Alright, 12 divided by 3 is 4. 4 minus 10. That should be equal to negative 8 plus, what's 6 divided by 3? That's 2, right? Alright, and 4 minus 10. 4 minus 10, it's going to go into the negatives. 4 minus 4 is 0, so this goes all the way down to negative 6. Just calculator is your friend. If you can't do this on your head, that's okay. So use that calculator. So let's get negative 8 and add 2 onto it. And, alright, it was correct. 1-24. If an input of negative 9 is put into each of the machines at the right, what is each output? There's my machines. Okay, so let's do one of them. Let's drop in negative 9 to this one. So we replace x with the input. So y is going to be equal to negative 9 squared plus 3. Don't forget to put parentheses. It's an input. Negative 9 squared is that number times itself. That's negative 9 times negative 9. Alright. And don't forget about this thing. If we have a negative times a negative, answer is positive. Positive 81 plus 3, 84. So the first output is 84. Alright. Now if we take the second machine and we drop in negative 9, let's see what happens. We're going to get y equals square root of negative 9 minus 2. There's a problem. Uh-oh. You can't square root a negative number. So there is no output possible. Why? You can't square root a negative number. The idea is square root of 9 is equal to 3, right? Because 3 times 3 is going to get you back to that original number. So if you are square rooting negative 9, what number times itself will get you back to that original number? So what number times itself will get you to negative 9? Now if you say 3 times 3, that's not negative 9. If you say negative 3 times negative 3, that's positive 9, still not negative 9. So there's no two numbers. Remember, these have to be the same because the rules of square root. No two same numbers can get you to negative 9. No output possible. Alright, so that's A, and you can also do B as well. Alright, Wednesday homework. solve the following equations. So this method is called cross multiplication. When you have a fraction on each side of the equation, you cross multiply. I'll do the one with pi in it. You can do the other one. Alright, so you cross multiply. You do pi times 4 is equal to, and then this one's going to be a times 7. Alright, now we want to solve for a. Pi is just a number. Remember, pi is equal to like 3.14 ... So to isolate a, let's rewrite this. Pi times 4 equals 7a, right? A times 7 is just 7 times a, same thing. You divide both sides by the number in front of a. Or in this case, the number that's being multiplied by a. How do you undo multiplication? With division. So a is going to be equal to pi times 4 over 7. Alright, now if you want to like approximate the answer, let's check. Let's see, this has a pi button on it, so we do pi times 4, and then we divide that by 7. What do we get? So a is going to be approximately 1.795. (1-29). Evaluate the following absolute value expressions. Let's look at B and D. So absolute value, kind of like PEMDAS, right? We have to do the inside of the absolute value first. If there's operations on the inside, in this case there is, it's 5 times the absolute value of 2 minus 8. So we go inside first. 2 minus 8 is -6, right? 2 minus a bigger number, it's going to go into the negatives. So it's 5 times the absolute value of -6. And remember, absolute value makes every number inside positive. So it's just 5 times normal 6, which is 30. And how about D? D is going to be 14 subtract. And again, absolute value, you go inside the absolute value sign first, and you do any operations in there. So what's that going to be? The absolute value of -10 plus 3. Well, -10 plus 3, -7. How'd I get that? Well, use a calculator. If you can't use a calculator, think about the number line. If you have a -10 and you're adding onto it, it's getting closer to 0. It's getting less negative, -7. So it's 14 minus 7, right? Absolute value of any number just makes it positive. So -7, absolute value sign goes away and it becomes +7. So it's 14 subtract 7. 1-30. The solution to the equation x to the power 3 equals 64 is called the cube root of 64. The idea is similar to the idea of a square root, except that the value must be cubed, multiplied by itself 3 times to become 64. One way to write the cube root of 64 is using the notation, this is cube root of 64. Use this information to evaluate each of the following expressions. Okay, so what they're saying here is what value multiplied by itself 3 times. That's what we need to find. So this is, we're cube rooting 64, so what number times itself 3 times will get us to 64. Alright, and that's going to be 4. And here's how that works. 4 times 4 is 16, and 16 times 4, 6 times 4 is 24, carry the 2, 4 times 1 is 4, plus 2 is 6, 64, so that works out. So because 4 times 4 times 4 is 64, that means the cube root of 64 is equal to 4. Your calculator should have a button, if you don't like that. So mine is, let's see, looks like mine doesn't, but your calculator should have a button for cube roots. How about this one? This one's kind of fun. So cube root of -8. Remember, the question is what number multiplied by itself 3 times will give me -8? Now you might be thinking no solution, but you are wrong. You can cube root a negative number. And here it is. Let's check. -2 times -2 times -2. So remember this thing. -2 times -2, +4. But then we multiply it by -2, and a positive times a negative makes -8. So the cube root of -8 for that reason is equal to negative 2. 1-32. Chadi performed a series of jumps on a trampoline. Her coach measured the height of each jump. The coach's data was recorded over here. Graph the data on this graph provided below. Jump number 1. Okay, so let's call this jump number on the x-axis, and let's call this height in feet on the y-axis. So if we find jump number 1, we should go up 0.5 feet, halfway between 0 and 1. Jump number 2, let's go up 0.9, almost a 1. Jump number 3 is 1.6, a little bit more than 1.5. Jump number 4 is 2.9, so you find 4, go up to 2.9. Jump number 5 is 5.2. So there's my graph. Now if we describe this graph, the jumps are increasing, right? As x increases, y also increases. Okay, it's non-linear. It's not a straight line. Another way of saying that is it's curved. If you look, nowhere is there a dot on the x-axis, so there's no x-intercepts. And then if you check the y-axis, there's no dot or there's no crossing of the y-axis. So we'll just say no x-intercepts or y-intercepts. There's neither. So those are some good ways to describe a graph. Alright, C is kind of asking you for reasonable limits, maximum heights for the jump. Just think like, what is a reasonable jump height on a trampoline, right? How high could you really go? And what is like the minimum? If you're jumping on a trampoline, what's like the minimum height of a jump? Something to think about is, can it be negative? Can a jump be negative feet? No, right? That doesn't really make sense. So think about that as you answer C. Let's do, let's see, how many more of these are there? There's 2 more. Let's do 138. Determine the corresponding outputs for the given inputs of the following functions. If there's no solution, say why not. Be careful. In some cases, there may be no solution or more than one possible solution. Okay, let's check number, let's say B and D. And you can also do A and C. So I'll help you with B and D. B, remember when you have an input, that number gets substituted for x, and you evaluate that expression for x. So f of 2 equals 3 raised to the power 2, and then we're going to add 1 onto that. Now 3 raised to the power 2, that's 3 times 3, right? 3 squared. A squared means you multiply the number by itself. So it's 3 squared, and then we add 1 onto it. That's going to be 9 plus 1. It's going to be 10. So f of 2 is equal to 10. The input is 2, and we just found the output, which is 10. Part D. F of 3, the input is 3, and the output, to get that, you take the input and you replace x with that number. So that's 3 minus 5, and we take the square root of all that. So that's going to be, well, 3 minus 5, 5 is bigger than 3, so it's going to go into the negatives. It's going to be negative 2. And there's a problem right there. No solution, or not possible. And remember it said to explain why not. No solution, you can't square root a negative number. Alright, last one. A and C is what I'll do. So if f of x equals 2 raised to the power x, then f of 4 equals 2 raised to the power 4, which happens to be 16, right? Because 2 times 2 times 2 times 2. 2 to the power 4 is 2 multiplied by itself 4 times. And that's 16. Now f of 1 is equal to 2 to the power 1. Replace x with the input. The input is inside the parentheses, and so the output is given by 2 to the power 1, or just 2. Try the same thing for B. With C, it's a little confusing. The input is t, so the output is what you get when you replace x with whatever the input is. In this case, t. So that one's kind of strange. F of t equals 2 to the power t. The answer still has a letter in it. That's okay. That one's